Alright, let's talk a little bit about differential equations. A differential equation is just an equation where we're told that the derivative is equal to some function, or some combination, some expression. We start with the very simplest type, which is one like this that I have written down here, dy dx equals cosine of x. Now, this one's simple because we know that cosine is the derivative of sine. So we can say that the solution, or a solution, to this equation is y equals sine x. Okay. Now, one thing you need to note when we're dealing with differential equations, the solution's not a number, it's not a value, it's another equation. When we talk about solving a differential equation, we're talking about finding out what y equals. And so one solution to this differential equation is y equals sine x. But then I think about, but wait a second, what if I had y equals sine x plus 5? And then I say, well, what is dy dx for that function? What is the derivative of sine x plus 5? Well, of course, derivative of sine is cosine, but the derivative of 5 is 0. So here we have two solutions to the original differential equation, and we start to see that that 5 could really be anything. It could be a 0 like it was originally. That just is sine x plus 0. It could be 5 like in the second example. It could be 2 million. As long as it's constant, when we take the derivative, the constant just goes away. And so what we find is that differential equations have, instead of a single solution, they have a family of solutions. And we usually write that with a constant of integration, which we call c. So y equals sine x plus c is our constant of integration. Well, it's our solution. It's our general solution. We don't know what c is. To find that, we'll have to have some initial conditions, and that'll be another video. But this is a simple differential equation just because we can look at cosine and recognize right away that it's the derivative of sine. Now, other than these very simple differential equations, in AP Calculus we deal with one very small subset of differential equations called separable differential equations. They're separable because we can separate x and y to different sides of the equal sign, and that makes them easier to solve. So generally they take two forms. You can have, which is really one form, if you think of multiplication and division as really very similar operations. But so I've got it here. I've got we could have one where we have some function of x times some other function of y, or some function of x divided by some function of y. And the goal here is to get everything with an x on one side and everything with a y on the other side. It's really easy to do. We can see here if I divide both sides by g of y, divide by g of y, or if we think of it as multiplying by 1 over g of y, that works also. And then we could multiply both sides by dx, and actually I'm going to change this little 1 up here. Oops, change that to just a dx, and I'm going to multiply this side by dx, and then I say, well, g of y divided by g of y is 1, and dx divided by dx is 1, and so finally I get my separated equation, g of y dy equals f of x dx. Now I can do similar things over here, down here to this second one, and we would see that if I multiplied by gy on both sides and multiplied by dx on both sides, so multiply g of y dx, multiply g of y dx. Then over here the dx's divide out to 1, over here the g of y's divide out to 1, and I'm left with g of y dy equals f of x dx. And that's just our first step to solving most of the differential equations that we will solve. I've mentioned before in class that we're going to have 3 steps, and they will be separate, integrate, and solve. Now, this video is just giving you an idea of what a differential equation is, and specifically what a separable differential equation is. And in the next video, I'll actually show you some examples of separable differential equations that we want to solve.